Okay, let's now look at question 2.2. So our goal here in each of these is to solve for x. Okay, so 2.2.1, we have 2 minus 16x to the power 3 over 2 equals to 0. Okay, so let's start by putting these on each on their own sides. Okay, so I put 2 equals to 16x to the power minus 3 over 2. Okay, and remember our goal here is to try and isolate x. Okay, so the first thing to do is to get rid of this coefficient. So let's divide both sides by 16. So on this side I'll have 1 over 8 equals to x to the power minus 3 over 2. Okay, because remember this was 2 over 16, so that's the same as 1 over 8. Okay, now 2 over 8, that's the same as 2 to the minus 3, right? Because it's just reversing. If you normally had this expression, that would be the same as 1 over 2 to the 3, which is the same as 1 over 8. So I just did that in reverse. Okay, and then this is still equal to minus 3 over 2. Now let's talk about how to get rid of this ugly looking exponent. Remember I said the goal is to isolate x. Okay, and that's the same as x to the power of 1, right? Those two are the same thing. Okay, so how do I take x to the power minus 3 over 2 and convert that to x to the power of 1? Well, I do that by finding something to multiply this exponent by that will give me 1. Okay, now to make something 1, you basically have to multiply it by its reciprocal. So what does that mean? So I'll multiply it by its reciprocal, which means that I take the denominator and make it the numerator, and I take the numerator and make it the denominator. Okay, and I keep whatever sign it has. So if it is minus, I keep it as minus. So let's see what that does. 3 times 2 is 6, 2 times 3 is 6. Okay, and a negative times a negative will leave it as positive. So I'll have 6 over 6, which is the same as x to the 1. Okay, so let's do the same thing here now. I'm going to multiply this by minus 2 over 3. Okay, it's a reciprocal. But now remember, whatever I do on the right side, I have to do on the left side. Okay, so let's do it on the other side as well. Let's multiply this by minus 2 over 3. Okay, so on this side I'll have 2 to the power of, the minuses will cancel each other out, and the 3's will cancel each other out. So I'll just have 2 to the 2 on this side. Okay, and here I'll have x, because remember that's what we're trying to get to. This is going to cancel each other out. Okay, and then 2 to the 2 is just 4. Okay, so x is equal to 4. Now again, you take your answer, you substitute x, here you put 4, and if you get 0, that means your answer was correct. Okay, let's move on to 2.2.2. It says 4 to the x plus 8 equals 9. 4 to the x plus 8 equals to 9 times 2x, 2 to the power of x. Okay, so to simplify this here, let's start making this a bit simpler. Okay, so let's say 2, remember 4 is just 2 squared. Okay, so 2 squared to the power of x, and we can just write that as 2 to the power of 2x. Okay, plus 8 equals to 9 times 2x. Okay, so let's bring this to this side here. So this will become minus 9 times 2 to the power of x plus 8, there's a plus 8, equals to 0. Okay, now let's say let 2 to the x equal k, for example. Okay, and the reason we're doing that is because remember this can be written as, this here can be written as 2 to the power of x times 2, right? So it's basically 2 to the x squared. Okay, so just keep that in mind. So if we have, if we're setting 2 to the x as k, this will now become k squared, right? Because remember I said this can be written as 2 to the x squared. Okay, and then this will become minus 9k plus 8 equals 0. Okay, and now it's a simple case of solving this. So let's find two numbers that when I add them together I get minus 9, and when I multiply them I get 8. Okay, so let's try. K squared minus 8k minus k plus 8 equals 0. Okay, so if I take minus 8 minus 1, because remember saying minus k is the same as saying minus 1k, that'll give me minus 9. And if I take minus 8 times minus 1, that'll give me 8. Okay, so when I added them, I got minus 9. When I multiplied them, I got 8. So that means those will work. Okay, so let's get rid of this. And now it's a simple case of just factorizing. So, okay, so I have k minus 8, k minus 1, because this was a common factor, so I factored it out, equals to 0. Okay, so I have two things now. I can equate each of these to 0. Let me just make this a bit neater. So this was k minus 8. Okay, so my two options are k is equal to 8 or k equals 1. Okay, now I'm just going to take this and bring it here. So let's start with k equals 8, right? And remember, k is 2 to the x. Okay, so I could say 2 to the x equals 8 or 2 to the x equals 1. Okay, now this is a simple thing of just trying. So 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8. So therefore, x equals 3. And on this side, remember if I raise anything to the power of 0, it gives me 1. So x equals to 0. Okay, so there's our two answers. Now again, you take it, you substitute it into x, and it must give you, or you can put it in here, and it must give you 0. And you try that for each one, and then you'll know if your answers are correct. Okay. Let's now look at 2.2.3. So I'm just going to do it over here. Okay. So 2.2.3. The root of the xth root of 9 equals 243. Okay. Now how do we solve this? This looks very ugly, but I assure you it's very easy. Okay. Firstly, let's understand what does the sign mean. Okay, in the context of exponents, remember if I say, let's say I say the root of x, right? That's the same as saying x to the power half. Okay, if I say the third root of x, that's x to the 1/3. Okay, and so on. So if I say the xth root of 9, that's the same as saying 9 to the power 1/x. Okay, so let's keep that in mind. But before we even do that there, let's simplify what's inside the root. Okay, 9 is the same as 3 squared. Okay, and 243, if you do some trial and error, you'll realize that it's 3 to the power of 5. Okay, so let's call this, instead of saying 243, let's say 3 to the power of 5. Okay, now let's recall what I was saying earlier, right? This is the same as saying 3 squared to the power 1/x. Okay, is equal to 3 to the 5. Now how do I deal with this? I just multiply it out, right? So 3 to the power 2/x equals 3 to the 5th power. Now if I have the same base on either side, I can get rid of the bases and just equate the exponents. Okay, so this will become 2/x equals to 5. Okay, and then it's a simple case of isolating x and solving for it. So therefore x is equal to 2 over 5. Okay, and again, take this answer, substitute it in here, and see if you get the correct answer. And if you do, that means your answer is correct. Okay. Let's move on to question 2.3. It says simplify the following fully. Okay, it's a very ugly looking expression, but let's deal with it. So we have p squared minus q squared times p plus q to the power 5 over 2 all over p minus q to the power 1 over 2. Okay, now let's start by looking at this. Okay, if you look at that, that should immediately remind you of difference of two squares. Okay, so root and then p plus q, p minus q. Okay, and then this whole thing multiplies by p plus q to the power 5 over 2. Okay, and then the bottom one, if you look at half, remember I was explaining on top here, that's the same as the root of that. Okay, so this is the same as saying the root of p minus q. Okay, so let's see now. When it comes to two brackets being multiplied under a square, I can just isolate them. Okay, so I can say p plus q times the root of p minus q. Okay, so I just took this and I broke it down into these two parts. Okay, and this remained the same, so I'll just bring that down. P plus q to the power 5 over 2. Okay, and at the bottom we had the root of p minus q. Now if you look at this whole thing, the root of p minus q and here the root of p minus q, those are common, so I can just cancel it out. And then I'll have p plus q to the power of a half times p plus q to the power of 5 over 2. Okay, so I just took the square root and I made it half, and I brought that down. Now we have a common base and we're multiplying two exponents, so I just add the exponents together, right? So I'll have p plus q to the power, and I'll just use my calculator now, 1 over 2 plus 5 over 2 gives us 3. Okay, so that's the final answer.